Alright, ladies and gentlemen, here we go. Algebra, Chapter 5, Section 3, Solving Systems of Equations by Elimination. Now, previously we looked at solving by substitution, but sometimes we don't know something about one of an item, okay? But here we know something about a group of items, right? We have 3 Mr. Fuzzies and 2 Mr. Furballs, and 1 Mr. Fuzzy and 2 Mr. Furballs here. Alright, so what we could do here, since we know that these scales are balanced, so this is the same as that. That means I could take that off, that same amount off of these scales up here, and it'd still be balanced. So I could take off 1, 2, and 1 of these guys. And then on this side, since it's balanced, if I take off 1 stack of 5 and 1 stack of 4, then those scales are still balanced. And now I could split them up into groups of 2, and I could find that 1 fuzzy is 5. Alright, so in algebraic terms, what that looks like is if you have an expression here, 3x plus 2y, we could solve this for x and use substitution, but another strategy would be we can subtract all of this right here. Now, if I subtract all of this from this expression up here, I do 3x minus x, that would leave me with 2x. I'd have to subtract this also, 2 minus 2y would leave me with 0, so those two would cancel out, which is my goal. I always want to cancel one of the variables out, and then 10 minus 9 is 10, then divide that by 2, and x equals 5. Once I've found x, now I'm going to plug that back into one of these. I plug it into the easier one, so 5 plus 2y is equal to 9. Subtract 5 on each side, and 2y is equal to 4. Divide by 2, and y is equal to 2. So my answer is 5 and 2, the solution to this system of equations. Okay, now when I subtracted, I had to change the signs of everything, and that's something you need to keep track of if you're choosing to subtract. I'll show you a slightly different method. You could also add. Okay, if the signs are already opposite, then we can just add the entire expression. Here, 3 plus 3, that would give us 6x. Here, positive 2 plus negative 2, those would cancel out because their signs are opposite. And then over here, 4 minus 4 would give us 0, so divide by 6. Obviously 0 divided by anything, x equals 0. Plug that back into one of those equations. 3 times 0 plus 2y is equal to 4. 3 times 0 is 0, so 2y equals 4. Y equals 2. Our solution is 0 and 2, and I can always check that. Plug that back into the other one. 3 times 0 minus 2 times 2 is equal to negative 4. This cancels out, and negative 2 times negative 2, negative 2 times positive 2 is negative 4, and that equals negative 4. Alright, sometimes your coefficients aren't the same and they aren't opposites. So what you have to do there is you have to make one of those terms opposites. So I can multiply one of the equations to make it an opposite. So I see which one's easy to multiply. Now 10's a multiple of 5 and 6 is a multiple of 3, so it doesn't really matter in this case which one I multiply. Both ones would work. So I'll just multiply this entire one by 2, and that would give me negative 10x minus 12, y is equal to 46. Now, notice I still have the same coefficients, and what I'm going to do here is I'm going to change that and multiply that by negative 2, which changes all the signs, makes that positive, positive, and this one negative. Because now when I carry this equation down, right here, carry that down, I'm going to have minus 10x plus 3y is equal to 1. Now I can just add these two when they have opposite signs. Then that cancels out. I get 15y is equal to negative 45. Divide by 15. And y is equal to negative 3. And then plug that back into one of these two. I'll plug it into the first one, negative 10x plus 3 times negative 3 is equal to 1. So negative 10x minus 9 is equal to 1. Add 9 to each side. Negative 10x is equal to 10. Divide by negative 10, and x is equal to negative 1. So my ordered pair is negative 1, negative 3. And I can always check that by plugging it back in to the other equation. Alright, so write down these steps. Step 1A is write the equations so the like terms align. Okay, that way, if they're aligned, then I can subtract them. If one's in standard form, the other's in slope-intercept form, rearrange them so I can align the terms. And if necessary, multiply to get opposite or same terms, whichever strategy you prefer, adding or subtracting. Then we add or subtract the equations to eliminate one variable and solve. Third, plug in the value found in step 2 into one of the original equations and solve. Lastly, remember to write your answer, your solution, as an ordered pair. Alright, so solving by elimination. If I want to solve this one right here, go ahead, pause it, and practice this yourself. Alright, pause the video now. Okay, check your work. Did you eliminate these by adding? Go through, see whether this is what you got. Alright, again, practice this one, see what strategy you want to use. Pause the video and go ahead and work this out yourself. Okay, and now check your work. See if this is what you did. Did you get 6 and negative 3? Alright, now sometimes we have to multiply one equation, so go ahead, pause the video. Practice this one by multiplying. Okay, one strategy you can use is multiply to get the same term. So 10x and 10x. However, then we have to subtract. So the other thing you could do once you have that, you could just go through and multiply the whole thing by negative 1. And now do minus, minus, minus. Change all the signs. And now we can follow those signs exactly. That cancels out. Here we get 22y is equal to, and then this is negative 132. And then divide by 22 on each side. And that gives you y is equal to negative 6. And there's your answer. If you plug back in the negative 6 into one of these equations, and you get x is 4, and there's your ordered pair. Alright, now sometimes you might have to multiply both equations. Notice that I can't multiply 4 to get 5, can't multiply 2 to get 7, and not the other way around. So sometimes you need to multiply both, so you have to find the least common multiple. So either you want to make 5 and 4 both 20, so multiply by 5 and 4, or you want to make 7 and 2 both 14, so multiply by 7 and 2. I'm going to go to 20. Okay, now again, I prefer adding, so what I'm going to do here, instead of multiplying by 5, I'm going to multiply by negative 5, because that changes these signs. That way I have opposite coefficients, and then I can eliminate just by adding all these up. Okay, I add these up, that cancels out. 38y equals negative 114. And then divide by negative 38, get y equals negative 3. Now plug that back into either one of these equations. So I'm plugging right here, negative 3 for the y. and solve, combine those, subtract 6 from each side, divide by 4, and x is 4. So my solution is 4 and negative 3. Alright, and finally, here is one of these examples again. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Okay, so 7 large, 5 small. Okay, there it says and. So 7 large and 5 small. Right? Location A receives 5 large vans and 2 small vans. So 5 large and 2 small vans for a total cost of $235,000. Okay, and location B gets 2 large vans and 3 small vans. So 2 large and 3 small, and for a total of $160,000. All right. Now we can solve this. This appears the total. So we could add these up and find a total there, but we have 2 already here. Now looks like I have to multiply both, because 2 doesn't multiply to get 5, 2 doesn't multiply to get 3. So I'm going to have to multiply both of these. I'll multiply this one by 2, and this one by negative 5 to get opposite coefficients. So that's 10 large ones for small is 470,000, and then negative 5 times 2 is negative 10 large, plus negative 3, which I'm going to just change plus a negative to minus 15 small ones is equal to negative 800,000. All right, tally that up. 4 minus 15 gives me negative 11s is equal to negative 330,000. We're going to divide that by 11, by negative 11. And so a small van costs $30,000. And then we plug that back in up there, 5L plus 2 times 30,000 is equal to 235,000. And so we get 60,000 right there. And 5 large vans is equal to 235,000. Subtract 60K minus 60,000. That's a 6 right there. And 5 large vans are equal to 175,000. And divide 175 by 5. And 1 large van and divide by 5. 1 large van is equal to $35,000. All right. And then you can plug that back in to check to see whether you are correct. And ta-da! Yes, we are correct. So that, ladies and gentlemen, is all we have for today. Lots of fun. And check back again next time.